Okay, thank you, Keith. Our next presenter is Michael Sprinkel. Mike is a licensed professional engineer in Virginia, and he currently working part-time as a senior research scientist for Virginia Transportation Research Council. Mike has been, ACI fellow since 2005. His involvement in ACI is very extensive. I'm sure most people know about that. So without saying, I won't say he recently awarded as ACI's Charles as Whitney Medal, recognizing of 50 years of outstanding applied research and leadership involving the rehabilitation of concrete structure. Welcome, Mike.
Okay, thank you for that introduction. It's such a pleasure for me to be here, to be part of this session to honor Fred. I've worked with Fred more than 20 years. I don't know the exact number of years, but he's just a great source of information and so fun to work with. So I'm glad at least I can share this tech note with you in honor of Fred. Okay, how do I advance the slides? Which one? That's forward? Okay, thank you. Okay, I was asked to, keep it as short as possible. We've got less than 30 minutes, and I'm one of the last two speakers, I think. Okay, so bruising, microcracking. This happens with concrete substrates during the concrete removal and surface preparation process prior to repair, and it's obviously detrimental to the bond between the repair material and the substrate, because if the substrate's cracked, you've weakened it. Preventing or minimizing bruising and its effect on bond is an important requirement for successful repair. So projects, what is bruising? Repair projects commonly involve removal of unsound concrete and replacement with new materials. So the concrete removal process can damage that substrate, resulting in various degrees of microcracking and fractures. And this is what is referred to in the industry as bruising. A bruised surface is a surface layer weakened by interconnected microcracks. And the next two figures are going to show you some pictures of cracks that were taken under a microscope. So this is, you can see in this slide, you've got cracks here, you've got cracks here, and the surface, the surface of the concrete's up here. And so usually these cracks are like 1/8 of an inch or less below the surface. But you can imagine if you bond a new material to the surface, it's not going to fail at the bond line. It's going to fail where these cracks are, because that's the weakest point. And the previous cracks were caused by a 30-pound breaker, and these cracks were caused by a 45-pound breaker, and these cracks are wider because you're impacting the substrate with a greater force. And then this is a picture that shows an overlay, and they've done a great job of surface prep. This is a bond interface, so the overlay is well bonded. Unfortunately, the milling machine caused all these cracks just below the bond line, so the overlay is going to fail with a little bit of the old concrete surface bonded to it. So how can it be minimized? There's a variety of methods. Chipping hammers, milling, abrasive blasting, and hydrodemolition that are used for surface prep, for concrete removal and surface prep. So removal of the unsound concrete to the rest of the concrete to a wide range of impacts and dynamic loads that can result in bruising. And as I mentioned earlier, it's usually about 1/8 of an inch below the surface. And there's really no criteria for the degree of bruising and the impact of that degree on service life. Some overlays placed on bruised surfaces have lasted a long time, but it's difficult to quantify because it depends on so many factors: the loads on the overlay and the thermal stresses on the overlay and so forth. So if you need high bond strength, bruising is going to hurt you more. If you don't need much bond strength, bruising is less important. Impact hammers being used. This is a milling machine, and you got a rotating drum inside of here. And this is the most common way historically for removing concrete on bridge decks. Say at 3/4 of an inch of the surface is milled off, and then you come back with an 1 1/4 overlay. And this is a picture of more modern milling heads. And you can see these things are small and they're pointed and they provide less of an impact per square inch to the surface, and they give you more of a cutting and grinding type action. And we've seen from taking cores from structures where this type milling head was used that bruising is really negligible. Now, if you remember, I don't have a picture, but the old milling heads, some of those things were big as your fist, you know, and then over time they made them smaller and smaller. So we can still do milling and not have undesirable amount of microcracking. You don't get microcracks by abrasive blasting, but you can use abrasive blasting. If your microcracks are close to the surface, you can blast them away with grit blasting. And shot blasting, this machine throws shot against the surface and vacuums it up, and it's a lot better than abrasive blasting. And again, if you got small cracks near the surface, you can remove them with a shot blast machine, and it's really fast and organized in the removal process. Today, more and more hydrodemolition is being used, and so with hydrodemolition, one, it does not cause microcracks. It removes concrete that needs to be removed, the weak concrete, and it leaves concrete behind that's sound concrete. And typically now, structures where overlays are going to be done, they'll mill them first just because it's so fast and cheap, low cost, and you'll have microfractures. But then they'll come back and go over the surface with hydroblasting, and that'll remove all those microcracks. How can you determine you've got this problem? You can do the bond test. And obviously, if you've got microcracking problems when you run the bond test, your overlay is going to fail, and the failure is going to be where the microcracks are. Another way is you take cores, send it to a petrographer, and they'll look at it and they'll tell you you got microcracks or not and how deep they are. Bruising can be minimized by selecting appropriate concrete removal equipment and techniques for the given repair application, and avoiding, whenever possible, something that's going to give significant microcracking. And the latter includes scabblers, scarifiers, bush hammers, pneumatic hammers, particularly the larger the hammer, wide chisel equipment, wide chisels. And bruising problems can be prevented by using methods such as abrasive blasting, water blasting, or hydrodemolition. Where the use of the more damaging methods is required to increase production rates, and that's usually the issue, fast production, more cracks, it can be mitigated somewhat by shot and water blasting as a final preparation step. Replacing commonly used sand and abrasive blasting, supposedly with materials like slag, flint carbide, or aluminum oxide, can help reduce the amount of damage, help remove the damage that you've got. And of course, the use of lightweight pneumatic chipping hammers with sharp pointed tools can also limit the extent of bruising. But obviously it's going to take you longer to remove the concrete. So this tech note has a lot of good information on bruising. If you want to be an expert on bruising, there's quite a few publications that were referenced and standards to prepare this tech note. And then my final slide is The bottom left is milling heads that don't do much damage, and the bottom right is where you've got some microcracking. And then I was trying my best to find some pictures of Fred and me together at ACI, and the best I could come up with is we were on TAC together. And one day they had a golf outing in the afternoon, I believe. We were up in Park City, Utah, and Fred and I don't play golf, right? And so Fred suggested, let's go. let's go down to the Great Salt Lake, spend the afternoon down there. And so Fred and I drove down there, and this is two pictures of the salt flats at the Great Salt Lake. And I tried my best to find one that Fred was in, but I couldn't. But it was a great afternoon that we had walking around there looking at the salt flats. And so with that, once again, it's been great working with you. Wish you the best in your retirement. And I'm glad I could be part of this celebration.